Good morning, students. Lesson 111. Hope you found your test fairly doable, and we will give you those scores back by Monday when we get those completed. Okay, today's lesson, we're going to start off with a couple of the first problems before we get to today's lesson. Let's do number one. Number one says Homer drove as fast as he could to get 60 miles ahead of May. If Homer drove at 17 miles per hour and accomplished his goal 20 hours after they both began. Let me just start this. Here's our distance equation. So Homer drove as fast as he could to get ahead of May. If you look at that, they both started off at the same time. And here's old Homer. At some point there, he got 60 miles. We just put the 60 ahead of May. So this is the distance of Homer. He's 60 miles ahead of May. Looks to me like when we have that, we will have a rate and time of Homer equals the rate and time of May plus 60. She was 60 behind. That's somewhat normal for girls. They usually get behind. Here we go then. We have Homer drove at 17 miles per hour. We see that. And we do not have a rate of May. Probably really slow, of course. Now what we do have is the times. And look at that again. They said they accomplished their goal in 20 hours. Processing that, I think they both had 20 hours, right? Let's put 20 for times on both of those. Now we have 3 of the 4. That's what we're always looking for. And this is by being side by side. 17 times 20, that should be 340 equals, we can just turn this around. We have 20, and we bring the RM down, plus 60. This is an easy one to solve. Put the positive 60 over on that side, becomes negative 60. This would be 280 equals 20 RM. Divide by 20. 2 and 8, 28 is 14. I believe RM equals 14. That's the rate. And up here, remember that's the miles per hour, right? So what are they asking for? How fast did May drive? 14 miles per hour. I don't know what she was driving, but that's a slow rate of speed for most vehicles. Okay, there's number one. And we'll look over here. I have number 7 to look at. Oh, this is the new stuff. Number 7 is new. I'm sorry, it is not. It is not. These are the functions in, again, I'll quickly tell you I do not understand this a whole lot. I'll show you the method. But A, B, C, and D, do you remember we make our own little homemade graph here? A little bit of a graph. And on the first one we have this. The next one is nearly the same, but it has a negative sign in front of it. The third one is a square root of x, and they included a negative 1 underneath. And the last one is x. I'm going to put the positive 1 on the back like this, if that's okay. So that doesn't mean it was on the front. Okay, do you remember what graph it is when we have a square root? This is your sign, something like this. Okay? And all of these have the square root of the same type of sign. It's just going to be turned around, positioned separate, different places. So this is simply we don't have any number, so we start off at the center, the 0 mark, and we take it up and over. That's a positive x. This one should be very similar. Besides, you notice we have a negative sign. What do you think we do with that? Start off the same place at 0 and go down this way. This is negative. Here we have a negative 1, now, and here's a positive 1. How do we know which line that we address here, the X line or the Y line? This is just my observation, not really teaching you much. Here is observation. Whenever it's included under the square root sign, or if it was included in a inclusive marks, then we deal with the X line. This one is not included in under here or in inclusive line, so it's going to be on the Y line. Can you learn that with me to start with? And whenever it is in an inclusive lines or in a square root, inclusive under the square root, like this one is, then we always use the positive. And this is -1. Well, here's our X line, right? This is going to become +1, and I think +1 would be somewhere like this. So we do our graph like this. Start off at that point. That's that one. Okay, this one again is not in the inclusive line, and it's not underneath of the square root sign, so it is on the Y line, and we use it just like it is. So that's a +1, and right here's where we start, and we go up and over. Not teaching you a whole lot, but showing you how to do it. That is number 7. Number 8, similar. This one is an x squared plus 1, and which one of those A, B, C, or D does that include? Now, if you remember, is this one dealing with the Y line or the X line? Remember, we just talked about this now. Does it have inclusive signs around it? It does not. Does it have the square root sign over it? It does not. So it is going to be on which line, my students? On the Y line. On the Y line, I'll just do it here for you. So in the Y line, where would it be? It would be on the Y line in a +1, somewhere right in here. Now read A, B, C, and D and see what it says. The first one says, shifted vertically up 1 unit, or 1 unit to the right, 1 unit down, 1 unit left. Which one is it? Which one is it? Does it address? 1 unit up. Is that right? This is where we have placed it. 1 unit up. So that is the answer. That is going to be A. That was number 8. Number 10. This is 10 and excuse me. 10 and 11 are the new stuff. Let's have a little corona, not bad, just a little bit of corona. 10 and 11, those are actually done completely different. So don't think that because they're new for today that they're the same. But I'll just show you what we do. Here's the original. That x plus 6 and 11. That's the original like this. Fairly simple. All we have to do is get this x in the middle and get rid of the +6. And then we can put it on the number line. And also look at it, what domain is it? It is integers. Let's not forget that. Integers are the exact whole number only, correct? When we get through here. Okay, so we got to get rid of the 6. What we do is just, because we have both directions and 2 numbers, we will use it on both of those numbers. If it's a +6, when we cross this line, it's going to become a -6. When it crosses this, it's going to become a -6. So now to rewrite this, 0 plus -6 is a -6. X, and 11 -6 is a 5. Now we will graph this. The number line, we're going to need 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. -6, -4, -2, 2, 4, and 6. Let's do the left side first. I see I have an arrow here going to the left, and it's -6, and it does equal -6. Remember, don't forget this integer, so I put it right here. On the other side, I have a +5, but it says it's less than +5, and it's not equal to it, so I have to go down to 4. Now it's the integers all the way between here, and only get the integers that, no, I'm sorry, does not have the zeros on that. I mean the arrows. It's only these in between. -6, less than 5 integers. The next one will be 4. So here we have all of your integers included. All right, I think we'll be dealing with this every day for a little while here. So you got that? That was number 10. Now 11 is not the same kind. This has the word or in it. The first one did not, but that or is what tells us it's going to be different. So we actually just deal with this x is less than -1 and x is greater than and equal to 5. What is our domain? Oh, don't forget your domain. The domain is reals, which means everything inclusive. Number line is here. 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Or -2, 2, 4, and 6. Deal with, when it has it or, deal with one side only. Looks like your arrow goes this way, and it's -1. It is reals. Here is -1 in reals, and it is not equal to it, so we put an open circle, and this way. Go to the other side. Can you figure that out on your own? It says x is greater than 5, going this way, arrow's going that way, and it also equals 5. So we not only put an open circle, because it equals it on reals, we put a solid dot. That is solving for number 11. Number 16. I just did this one because it's a little unusual from what we normally have solved. But maybe you on your own can think through how to do that. We have to get rid of the 4. That's our what's different. And when these are beside each other, understand this means that this is multiplied times that. So to undo a multiplication, we do what? We do the opposite, we divide. So we put this over on this side and put it underneath it here, and we divide by that. That is removing the 4. Now, does that make any sense? We have a square root of y equaling 5. We need to get rid of the square root sign, just like we've been doing in the past. We square this. What we do on one side, we do on the other. We square this side. By squaring this takes this out of the square root sign. 5 times 5, squaring that is 25. That should be our answer, but we want to check it. Y equals 25. I'm going to erase what's in between here and go back to the original. This was 4. Still with me? Here we go. Got rid of that. Okay, if we say that y is 25, let's check ourselves out. 25. So the square root of 25 is 5. And this is 4. Remember, we multiply it. 4 times 5 is 20. Does 20 equal 20? Absolutely does. So this was the right answer. That is number 16. Number 21. Graph on a number line. That one I did because it's a little bit unusual. It's not something you haven't done before, but let's just try this one. A -4 and a negative. This is all original. This is the original problem right here. Okay, I'd say the first thing we do is get rid of this -4, move it to the other side. It becomes a +4. So now we have rewrite it. It's still. This is 0, is that correct? Now we have to get rid of the negative sign, excuse me. Get rid of that, we change the direction of the arrow, and we can do nothing because zero, -0, +0, all the same, so now we still have 0. Now how are we going to write that on a number line? 2, 3, 4, -4, -2, 2 and 4. If you remember on your 4 graphs. I forgot which lesson we did that, but of the 4 possibilities we had, I hate to take the time to even show you that, but do you remember that we had 4 of these? You have it written on one of your practice sets. One of them is like this, and one is like this, and one is, do you remember that? Look back on those 4. You will see with your direction like this that the arrows go out. And where do we start? Normally we have some number. If it was -2 or a 2, then we would, remember we would circle the 2's and then go out from that. In this case, we start off, it's the same theory, but we start off from 0. So we're starting off from here, and we're going out, and we're going out. So in fact, there's no break. It's just straight through. That is number 21. And 22 yet. 22, you may or may not have your graph, but I can just make you a homemade graph here, and you can solve this one. We have -5 and a 2 and a 3 and -7. So if I go out here, -5 and up 2. I'm just getting the general idea. Over here we went down over 3 and down 7. It says find the distance between here. We don't have an actual graph. How can we do this? This was 3, and this was -5. So what's the difference between -5 and +3? 5 plus 3, that is 8. You can do this that way. All right. Now here we went up 2, and over here we went down 7. Up 2 and down 7 is a 9. So how do we get this distance between these two? Pythagorean theorem. 9 times 9 is 81. 8 times 8 is 64. Add those together is 145. Can you reduce this? If you take the 5 into it, it becomes a 2, 9, comes 29. You cannot reduce that. That's interesting. So we have the square root of 145 is our answer on 22. If you have a graph or to be able to go to, this is easier to do it on a graph, but this is the way you can do it without the graph. That's all it shows to do today. If you have any questions, you can give me a call. And you have a wonderful, blessed day. I'll see you tomorrow on lesson 112.